Hi all. In the previous lectures, we saw what is few shot learning, what are the ways to address few shot learnings. The way to address the to solve the few shot learning can be broadly categorized into two categories that we saw earlier. One is meta learning based few shot learning, and another is non meta learning based few shot learning. So in this video, we will introduce a few shot learning problem called few shot image classification problems and try to see various approaches based on meta learning and non-meta learning in the forthcoming videos to solve or to address the problem of few shot image classification problems. But at the same time, these approaches not only are targeted for this image classification problem, it can also be applied for the reinforcement learning and also regression problems, which we will be discussing in the section 4, how that classification few shot learning can be extended to the other domains. So what is few shot classification problems? So what is a classification task? A classification task is a supervised learning task where X is an input and Y is a binary output, or Y is an output label. The task is to fit a function with parameters theta using the training data where data samples are usually very large. If in case the data samples are small, then that is termed to be as a few shot classification problem. Usually it is very difficult to fit a parameter which can be generalized. So this is termed to be as a few shot classification problem. So usually, few shot classification task can be denoted as a MVK short task, where M is a number of classes and K is the number of example per class. Usually, K used to be a very small number compared to the number of classes, which is the other way around. Usually, in the other standardized classification problems. So these MBA short tasks are usually taken from these data sets in our case. Now we come to what is meta learning based few shot learnings. So before going to few shot learning based on meta learning, so we just give some overall idea that we already discussed earlier. What is meta learning? Meta learning objective is to similarly like approximate a function f with parameter theta, but here it tries to fit a functions over a distribution of tasks where the training is not having a training data, but training set has a set of task, training task, and tries to fit a parameter theta in such a way that the test task, uh, uh, when we are applied, the functions or the fitted model perform very well on the test task. So here, related to the classifications or MVK short task, we have a bunch of MVK short tasks which is been segregated into a training and test task. And MVK short training tasks are used to fit the parameters, and it is evaluated on the MVK short test task. So this meta learning approach can be used for the future learning, which is mainly have further three subcategories based on metric based meta learning, few shot learning, and optimization based meta learning solving few shot learning, and model based meta learning solving the few shot or MAK shot few shot learning task. So, what is metric-based meta learning and optimization-based meta learning and model-based meta learning is an objective of this forthcoming videos. And non-meta learning based will be given after introductions of this meta learning based uh, few short learning, which is the main part of this approaches for the solving few short learnings. So, what is metric-based meta learning, and how this metric-based meta learning can be utilized to solve the few short learning problems? So, before that, there are three kind of terminology applied here. One is metric-based learning, meta learning, and few short learning. So we already know what is few shot learning. We have a very few data sample and try to generalize similar to the how the human learns on the task, whatever it is surrounded by it. And meta learning, we know that we are trying to use the prior experience. We try to utilize the experience what we have attained earlier and to learn the new task in a very short time. So what is metric learning is, metric learning is a task of learning some kind of measurement utilizing a set of samples. For example, if we have two images and we have a third image, we try to identify this third image either belongs to the first or second image based on how much closeness it is to the image one or image two. And usually that measurement, how closeness is it would be like kind of a learning task called as a metric learning. This is somewhat similar to KNN. But usually the image data is a higher dimensional. The first on the first step of metric learning would be to an embedded learning. Embedded learning means like try to learn an embedded function so that the high dimensional input is been reduced into a low dimensional output, and further that low dimensional output would be taken into consider for a standard distance measurement like a Euclidean or a cosine similarity or L1 distance measurement. And that's what it is predicted here. So we try to make an embedded function g, and once that embedded output would be output would be taken for distance measurements. So we have this is what it is been defined here. Metric. This is what metric learning. And meta learning is we have different tasks of different task, and each task we try to make an embedded fun each task data would be trying to make a dimensionality reductions or embedding, and that embedding would be further that output of that embedding function would be taken to be as a metric distance measurement to identify where the unknown samples belong to that support set. So we have kind of so this is meta learning based metric learning based meta learning. And if we have a few samples during the test time, then that would be called as a few shot learning based on the metric based meta learning. So this is very clearly illustrated in this figure. We have a different task where m way k short task, where m is a number of classes. The number of classes can be, for example, here it is 4, and k is here is 1, and we are here to try to make an embedding function so that using a support set, and when the query is given, this query also being embedded using this function embedded. Once this embedded output of this query comes out, it tries to identify which this embedded is very close now to the output of this support set embedded using this distance function. This distance function can be either a standardized like Euclidean or cosine, or it can be learned similar to what we are learning in the embedding functions. So that output would give you which class this query data belongs to. Um, any one of these support set. Here it is 4 classes, and one shot only the test data is only one support set we have, and the query set when it is given, it tries to identify which one. In this case, it belongs to the second category. So this is what kind of metric based meta learning targeting MWay K-short K-short classifications problems. So we have randomly sampling we have a bunch of MWay K-short tasks or episodes, and those are randomly disintegrated into a training set and test set, and the training sets are randomly sampled and try to determine an embedding functions. And once the embedding functions are determined, the query set is also embedded and try to see in that embedded space how closeness that the query data belongs to any one of the training data in an embedded space, not in an original input space. So this is what this way of metric-based meta learning is utilized to address classification problem where the data samples are very low in number, which is I said earlier like MBK short task. So there are table 5 defines different uh, metric-based meta-learning feature classifications using different algorithms or different neural network models like Siamese networks, matching networks, prototypical networks, relation networks, JADM, TAPNet, and CTM. And it is whether that embedding function is a task independent or it is applied in this the embedding function is uniformly over all the tasks or it is task specific and how what are the neural networks are used for the embedding function, whether it's convolutional neural network or an LSTM, or it is a RESTnet or any other things has been utilized for the embedding function. Whether the D2 is a standardized like L1 or cosine or Euclidean, or it is been learned again by a CNN. So based on this differentiality, different networks are set, and how the objectives are set in each networks differentiates is different metric-based meta learning for solving these tasks using the deep learning application, deep learning fundamentals. So hopefully we try to see each one of these networks very briefly in the forthcoming videos. Maybe in the next video we will see about the other two way of solving other two way of meta learning methods like optimization meta learning methods and model based meta learning methods to target how that can be utilized to solve the few shot learning. Thank you.